Stres lah, apa ni?
Hadira struggle yang mana?
Ni rules of inference susah sangat lah.
Oh, apa kata Hadira tengok video YouTube ni? Diorang ni pandai tau dalam mengajar rule of inference.
In mathematical logic, an argument is a collection of statements called premises that are used to support a conclusion. These arguments follow a logical structure. For an argument to be considered valid, the conclusion must be true whenever all the premises are true. This idea is what we call a logical implication. You can see that this relationship can be written symbolically as P1 and P2 and ... and Pn implies Q, which means if all the premises P1 to Pn are true, then the conclusion Q must be also true. To prove or check whether an argument is valid, we use specific rules called rules of inference. These rules help us move from known statements to logically valid conclusions. In the next part, we will go through some questions using common and important rules such as modus ponens, modus tollens, syllogism, conjunction, and others that help us reason correctly and form valid arguments in mathematical logic.
Now, let's go through the first example to show the validity of argument using the rules of inferences. For this question, we are given 4 premises. First, not P and Q. Second, if R, then P. Third, if not R, then not S. Fourth, S or T. And our goal is to prove T. So let's see how to solve this question step by step. Firstly, we assign all the given premises as premise 1 until premise 4. From premise 1, not P and Q, we can use rule of conjunctive simplification and take only the not P part. As we can see from the rules of inference table, rule of conjunctive simplification lets us pick one part from the AND statement. So number 5 is not P. Next, we use premise 2, if R then P. Since we already have not P at number 5, we can apply modus tollens for number 2 and 5. Modus tollens says if R leads to P, but P is not true, then R also did not happen. So we can write number 6 as not R. Now, from premise 3, which is if not R, then not S. In number 6, we have not R from the previous step. So right now, we can apply modus ponens for number 3 and 6. By applying modus ponens, the not R will be gone and leaves with only not S for number 7. For the last step, we use premise 4, S or T, and we have not S in number 7. From the table, we can see that syllogism disjunctive can be used for this situation. So finally, we will get T from number 4 and 7 by using syllogism disjunctive. In the end, we managed to reach the conclusion T by following these logical steps. That means the argument is valid.
For the next question, we have P implies Q or R, S implies not Q, P and S. The conclusion is S implies R. Hence, I am going to show the validity on the argument using the rule of inferences. First, we need to write all the premises. Hence, number 1, P implies Q or R will become premise 1. Number 2, S implies not Q will become premise 2. And number 3, P and S will become premise 3. Next, for number 4, we will use rule of conjunctive simplification at number 3, which is P and S, that is marked as yellow color. Hence, we will get P. After we have used some premises, we can cancel them out as I mark at number 3. Next, for number 5, we will use modus ponens at number 1 and 4, that is marked as yellow color. Hence, we will get P or R. Next, for number 6, we will use implication at number 5. Then, we will get not Q Q implies R. Lastly, for number 7, we will use syllogism at number 2 and 6. Hence, we will get S implies R. Finally, after we have marked all numbers, we will get the same answer as the conclusion from the question. Hence, we can conclude that the argument is valid.
Next question we have, if P then Q, if not R then not Q, not R and not S, we got not P. So first, we must write all the premise. So number 1 is if P then Q in premise number 1. Number 2 is if not R then not Q is premise number 2. Number 3 is not R and not S is premise number 3. So second step is use rule of inference to prove the argument. So we continue to number 4. We look at number 3, which is not R and not S. We choose rule of conjunctive simplification in rule of inference. So not R and not S, we got not R in number 4. So we continue to number 5. We look at number 2 and number 4, which is not R and not Q. And number 4 is not R. So we choose modus ponens in rule of inference. So not R, if not R then not Q, and not R, we got not Q in number 5. So next is number 6. Number 6, we look at number 1 and number 5. Number 1 is if P then Q. Number 5 is not Q. So we choose modus tollens in rule of inference. So we got if P then Q and not Q, we got not P. So we can prove that the argument is valid.
Last question shows that the argument is valid. We are given P implies not Q and not R, then S or R, and lastly not S and T. Hence, we will need to prove that not P is true based on the given premises. Now, let's break it down step by step. We start with our 3 premises. First premises are P implies not Q and not R. And second premises are S or R. And lastly, the third premises are not S and T. From line number 3, not S and T, we need to apply rule of conjunctive simplification. It is to isolate not S. And now that will give us new line, which is line number 4. Now look at line number 2, which is S or R. Now since we know that not S is true, that means S is false. By applying the rule of disjunctive syllogism on the line number 2 and the line number 4, we can eliminate S. Hence, we are left with R. And that is our new line, which is line number 5. Next, we take line number 5, which is R, and apply the disjunctive simplification to get Q or R, which is the line number 6. And don't worry, this is a logical move to help us later on. Remember, our goal is to prove that not P is true based on the given premises. Now, in line number 7, we apply the De Morgan's law but in reverse because we want to convert Q or R into negation not Q and not R. The negation not Q and not R is logically equivalent to Q or R. Finally, the last step is we go back to line number 1, which is P implies not Q and not R. And from the line number 7, we now have the negation of not Q and not R. So, by modus tollens, if the conclusion is false, then premise P must also be false. Therefore, we can conclude that in line number 8 that not P is true. And this has completed our proof. Thus, the argument is valid. In simple terms, we move step by step using valid inference rule to show that the given premises, not P, logically follows.
In conclusion, rules of inference are the foundation of logical reasoning in mathematics. They provide the structure we need to meet valid conclusion from given premises, ensuring our arguments are valid. Each rule plays a crucial role in formal proofs and real-world logical analysis. Understanding and applying these rules not only helps in mathematics, but also sharpens our critical thinking skills. We encourage you to practice using these rules in different scenarios to deepen your logical reasoning. Thank you for spending your time watching this video.